Hi guys, we're going to be talking about perpendicular and angle bisectors today. Trying to how we can describe a set of points that are equidistant from the endpoints of a segment, or I should say, or from the sides of an angle. The learning goal is to prove and apply theorems about perpendicular and angle bisectors. We'll be defining equidistant and locus. We're going to be doing that right off the bat. Okay. When a point is the same distance from two or more objects, the point is said to be equidistant from the object. Okay? Equidistant sounds like equal. Tyler, you should be writing this down. Sounds like equal, because that's where we get equal from. Equal. E-Q-U-I. Equidistant. Okay? The same distance. Triangle congruence theorems can be used to prove theorems about equidistant points. A locus, which we're going to define because we'll talk about it, it's not in the same sets of standards as it has been in the past, but we still define it. A locus is a set of points that satisfy a condition. So, for example, today we'll say the perpendicular bisector of a segment can be defined as the locus of points in a plane that are equidistant from the endpoints of the segment. All right, let's look at this in context, guys. Let's look at some of this stuff. First off, we have what we call the perpendicular bisector theorem. Okay, perpendicular bisector theorem. Here's what that says. That says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay? What does that mean? If I tell you, look at this symbol right here. See this symbol? This symbol reads XY is perpendicular to AB. I also give you that YA is congruent to YB. What would we call point Y? The what? Not the point of origin. Here's a hint. It's in the middle. Midpoint. Very good. If it cuts it into two congruent segments, then Y is the midpoint, the middle point between A and B. Okay? And all we're saying is that if I extend this perpendicular bisector up, then XY is congruent to XB. I'm sorry, XA is congruent to XB. Y is XY. Another thing to notice about a perpendicular bisector, what kind of angle is formed right here? Right angle, okay? So there's a lot going on in this particular theorem, right? I've got a midpoint, I've got right angles, I've got congruent segments, and they create congruent segments, okay? The converse is just like the original. If a point is equidistant from the endpoints, it is on the perpendicular bisector. Basically, if I give you that XA is congruent to XB, and A to B are joined together, then XY is perpendicular to AB, and YA is congruent to YB. All right, let's move on here. If you're not done, you'll learn how to write fast. All right, here we go. Here we go. How would I apply such a theorem? All right, let's see how we can do this, guys. Trying to find the measure of B to C. Look at what happens here. Okay, look at what happens. If A to B is 38 and A to C is 38, are these two congruent? So if these are congruent to each other, that means that AD, no, it's the perpendicular bisector of BC. A to D is the perpendicular bisector of B to C. A perpendicular bisector does two important things. Forms a 90-degree angle and serves as the midpoint between those two segments. The midpoint, the middle point, cuts a line segment into two congruent segments. So if this is D, if D to C is 12, how much is D to B? So what's the total distance from B to C? That's how that works. Okay? That is how that works. That's the perpendicular bisector theorem at work. All right, let's try another one. Okay, here we go. I've got this. I've got TWB, UW. Notice TW is congruent to BW and a 90-degree angle is formed. Ring-a-ding, that is a perpendicular bisector. If I have a perpendicular bisector where TU meets BU, they are congruent to each other. Okay, I would set those expressions equal, solve for x, and plug x back in to get T to U. Let me see if y'all are getting this Dennington. I know you have an Alabama shirt on, but you can do this probably. If T to U is 28.5, what is B to U? Say what? Yeah, it's congruent, right? So if it's 28.5, what's the numerical value? I know numerical, the number value. If this is 28.5 T to U and it's congruent B to U, what is the numerical value for B to U? There we go. There we go. Right? 28.5. Because I could say, what is T to U? And you'd say 3x plus 9. And I could say, okay, what's B to U? And you'd say 7x minus 7. That's why I say numerical value. All right? It's cool. It's cool. Right? Next, I have what we call an angle bisector theorem. Here's what it says. If a point is on the bisector of an angle, then it is equidistant from the sides of the triangle, of the angle. And the converse says if a point in the interior of an angle is equidistant from the sides of that angle, it's the bisector, or it's on the bisector. Okay? So in this case, I have angle APB. It gets bisected by B to C. What does a bisector do? Cuts something in half. You cut a segment in half, you cut an angle in half. In this case, it cuts angle P in half. So APC is congruent to BPC. From that, I get to conclude the distance from C to A is congruent to the distance from B to C. And they form 90-degree angles. My converse tells me the same thing the other way around. If CA is congruent to CD, then PC is the angle bisector. So APC would be congruent to BPC. All right, guys, let's move on. Okay, let's see this in action here. Find the measure of B to C. Miss McCleary, do I have an angle bisector here? How would I know if I have an angle bisector? What would an angle bisector do? What? Your name is still Miss McCleary, right? I mean, you could be using an alias this week, considering the fact that your team got dog stomped 45 to 14 last week, and now, you know, the undefeated number 12 ranked Tennessee is coming in. You're right. We'll see Saturday if it means anything. I know that you might not be going by your real name, but on the roster, you're still Alyssa McCleary, so that's you. Is there an angle bisector here? What is it? I'm sorry, when you talk to yourself and you mutter under your breath because it's probably a shame where you're saying. I know, and now I'm asking a second question. Thank you, though. I appreciate your translation. All right, so what is the angle bisector? Hey, thank you. Ms. Bagwell, I know you. Is it you or is it? Oh, it's the Myers person in the back. Yeah, I know you guys always like to do things together in Dog Nation, but let Alyssa answer these. Alyssa, angle BAC is congruent to angle DAC, correct? Okay, good. You're done. Miss Myers in the back. Oh no, you went to sleep. I'm sorry. Alyssa, back to you. Are there 90-degree angles in here? Yeah. Okay. Myers in the back. C to D is 7.2. What is the distance from C to B? How do you know? How do you know it's congruent? You just wrote something down that would tell you that it's congruent. What did we call that? The angle bisector theorem. Check it out, y'all. Angle bisector theorem says that AC is the angle bisector of BAB. Then the distance from C to B is equidistant to the distance C to D. Equidistant, the same distance. Okay? The same distance. Right? So, check this one out. If I know that EFH, I'm trying to find the measure of EFH. If I know EFG is 50, this face, EFG is 50. Do I have an angle bisector here? How do I know? We have a theorem that we wrote down that talks about this. It says, if the distance from H to E is congruent to the distance from H to G, then that is an angle bisector. What does an angle bisector do? Go to Mr. McCleary. Mr. McCleary, what does an angle bisector do? These are simple questions. What does an angle bisector do? Ms. Klein, what does an angle bisector do? It cuts an angle in half. So if the big angle is 50, how much is half of it? Okay, 50. Okay. Okay, 50. Okay, 50. Coach, thank you. You should write. Stay away from Spanish. All right? All right. Ooh, here's a good one. Oh, dear. Y'all write this one down. I want y'all to work on this one, okay? Given that angle WYZ is 63, given that that angle is 63 degrees, that X to W is 5.7, Z to W is 5.7, tell me what X, Y, Z equals. Okay, Mr. Dansby. Mr. Dansby, you're up, sir. All right. I am told that XW is 5.7 and ZW is 5.7. Are those the same measurements? Do what? They are. I was just looking for all right, well, quit listening to Ms. Myers. Start listening to me. See, like right now, how you're not doing it? Okay. So XW is 5.7, VW is 5.7. Are those the same? If measurements are the same, do we just call them congruent? So can you conclude that these two are congruent? Okay, Jordan. I have a theorem that says that if the measurement from one point to an angle is equidistant from the same point to the other side of the angle, it serves as the angle bisector. Yes or no? Yes. Okay, we're doing okay. All right, so if this big measurement, I'm sorry, if WYZ, if this measurement is 63, what would the entire measurement be? Here's a hint. This measurement 63, this measurement is also 63. Calculate that up for me. Tell me what the whole thing would be. Do you have a calculator? All right. Add it up and tell me what you get. Perfect, Jordan. 126. If the angle bisector, whenever the distances are equidistant, you'll have an angle bisector. And they form 90-degree angles. That should also be a vector. Okay? Look at this one. We'll do this one together. S is equidistant from each pair of suspension lines. Okay? Those are equidistant. If those are equidistant, what can I conclude about QS? What is it going to be? The what? This for clarity.
Yes.
What would QS be in relationship to PQR? This part right here would do what to this angle? Split it in half. When something splits an angle in half, what do we call it? It serves as the what? Bisector. The angle bisector. Very good. Okay, so it would be the angle bisector. All right. Sometimes, everybody, sometimes you're going to see this. Write an equation in point slope form for the perpendicular bisector of the segment with endpoints at 6, -5, and 10, 1. First thing you'll do, graph your points. Graph your points. Yes, Data?
I read that like C and D is kind of like CDs.
Yes, Coach knows all about those. Those are popular in this day. After I graph my points, y'all listen. After I graph my points, I need to find the midpoint. If you haven't written down your midpoint formula yet, you've got 10 seconds to do it right now. X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2. That gives me the midpoint of the segment. Okay? The midpoint formula, X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2. Coach, you got the new set? There you go, babe. I got it. You got it? You cool? Cool, man. Now, this is really important. After I find the midpoint, I need to find the slope. Okay? I need to find my slope of CD. But here's where you got to put your thinking cap on. This is the hardest part of the whole day. If I find the slope of C to D, okay, if I find the slope here, that doesn't do me any good if I'm looking for a perpendicular bisector. Perpendicular bisectors form 90-degree angles, right? If I do this right here. Make me a T. Come on, do it. Everybody do this. I'm waiting. The sooner everybody does this, the sooner I'll move on. Thank you, ma'am. Okay? Just Myers is giving me this. A little different, right? Right? Give me this. Give me this. Okay? All right. How do I find my perpendicular bisector? I'll tell you how. It is the midpoint along with, watch how this works, the opposite reciprocal slope. Opposite reciprocal. From positive to negative or from negative to positive. Reciprocal. 3/2 gets switched to be 2/3. The opposite of positive 2/3 is negative 2/3. Which means I go from rise 3, run 2 to rise negative 2, run 3. Down 2 to the right 3. Weird indeed. Okay? That's all I got. Do I have